Okay, so picture this. You're floating in space. It's just you, out there in the deep, silent black. And right in front of you, there's this perfect circle of nothing. It's not just dark, it feels like it's eating the light around it. You drift a little closer, and at first, everything seems fine. But then, you notice the stars behind it. They're starting to stretch, to warp, like you're looking through a funhouse mirror. Time itself starts to feel, well, just strange. And before you even have a chance to think about turning back, this terrifying realization hits you. You're not just looking at a black hole anymore. You're falling into one. So let's talk about this incredible, absolutely one-way journey.
So what in the world is this thing you're falling into? Well, a black hole is basically what's left over after a giant star dies and collapses in on itself. It gets squeezed down into a point that is so unbelievably dense, its gravity becomes an inescapable trap. Nothing gets out, not even light, which is, the fastest thing in the entire universe. As you start to fall, you might be thinking, hey, maybe I can just orbit this thing, right? Like a planet around the sun. And yeah, from way far away, you could. But as you get closer, the rules of the game change, big time. Gravity doesn't just get stronger, it gets uneven, dangerously uneven. The pull on your feet suddenly becomes exponentially stronger than the pull on your head. Your whole body is being stretched out, and this process, it has a name that's both kind of hilarious and absolutely terrifying: spaghettification. You are literally being pulled apart, atom by atom, into a long, thin strand of you. Okay, but here's where things get really weird, and it all depends on the size of the black hole. If you fall into a smaller one, a stellar mass black hole, that whole spaghettification thing happens before you even get to the edge. It's a quick, violent, and very definite end. But if you're lucky enough to be falling into a supermassive black hole, like the monster at the center of our galaxy, the experience is much, much stranger. See, with a supermassive black hole, the gravitational forces at its edge are actually gentler, so you could cross its boundary completely intact. This boundary has a name: the event horizon. And you gotta remember this, it's the ultimate point of no return. Once you're past it, there is no going back, ever.
And this right here is one of the biggest mind benders in all of physics. For someone watching you from a safe distance, they'd see you slow down as you get closer to the event horizon. You'd get redder and dimmer, and eventually you'd look like you were frozen in time right at the edge before just fading away. But for you, from your perspective, you feel nothing special at all. You just sail right across the line, continuing your fall, with no clue you just passed the universe's ultimate one-way door.
So you've crossed the line. You're inside. And this is where the rulebook for reality as we know it, well, it just gets tossed out the window. And the very first thing to break? Time itself. And we have Albert Einstein and his theory of relativity to thank for this little piece of cosmic insanity. The basic idea is that gravity actually warps space and time. So inside a black hole, where gravity is off the charts extreme, time is stretched almost to infinity. So get this, for you, as you fall deeper, maybe only a few minutes have passed, but you're looking out at the universe, and time there is screaming forward. You could literally watch the entire future of the cosmos play out like a fast-forwarded movie. You'd see new stars ignite and old ones die. You'd watch entire galaxies crash into each other. You might even see the universe itself grow cold and dark, all in what feels like just a few moments. So you've just witnessed the end of everything. What now? Well, you're still falling. You're heading towards the very center, towards a place that is maybe the greatest mystery in all of physics. You're approaching the singularity. The singularity is, well, it's a point with theoretically infinite density and basically zero size, where all the stuff that made up the original star is crushed down. It's a place where our understanding of space, time, gravity, all of it just completely breaks down. We literally don't have the science to describe what happens there. So what could possibly be waiting for you? Well, there are a few ideas. The most likely and least fun is that you're just crushed out of existence, instantly. But there are other, wilder theories. Some physicists think a singularity could be a gateway, maybe a wormhole that zips you to another part of our own universe, or crazier still, to a whole other universe entirely. I know, this all sounds like something straight out of a sci-fi blockbuster, a real mind-bender. But here's the kicker. Black holes are real, like 100% for sure real. This isn't just math on a chalkboard anymore. We have proof.
Back in 2019, humanity did something absolutely incredible. Scientists linked together telescopes from all over the world, essentially creating one Earth-sized telescope, and with it, they took the first ever direct picture of a black hole's shadow, that glowing ring of fire around a perfect circle of black. It proved they're out there, just like Einstein predicted. So when you really think about it, falling into a black hole isn't just a fall. It's a journey where space collapses in on itself, time shatters into a million pieces, and the entire future of everything becomes your own private movie. It's the one place in the universe where our understanding of reality just ends.
Which leaves us with one final, pretty intense thought. Imagine you had the choice, a one-way ticket to witness the most extreme reality the cosmos has to offer. You know there's no coming back. You know survival is impossible. But you would see things no human has ever seen, or could ever see. Knowing all that, would you go?